those who are online, are you able to hear me?
Yes, sir.
Good morning, guys. Yeah. So what were we doing in the previous class? We are doing few problems, right, which were based on equations of motion. So can you tell me what are the chapters you have for test? Physical world test. Okay. Units and measurements. Till acceleration. So we are done. So we are done with it, correct? Okay. So the only thing pending is you writing a test is pending up. When is your test? You told August 1st it's starting. Okay. What about you? You didn't get initially. What about you? Motion is statement. So it's almost the same thing. August 3rd is what day? Wednesday. Okay. August 3rd. So for you, when is it starting? August? Okay, when is physics? Physics is 3rd. Do you have a gap between each exam? It's continuous. Is it a half day school or you need to write the exam and then come up, right? Okay. What about you? Full day. For you, it is not at most. Okay. So you have continuous exams, right? First, second, third, you have it like that. Yeah. Because I want to conduct one test of this so that I can help you if there are any problems. Physics is on Thursday. Okay. Can you write a test on 2nd? 2nd of August. Just the day before your exam. It will be like a mock test. So what I'm saying is I'll give you a strategy. So today is 28th. Okay, since we have already completed all the portions. Since we have completed the theory part, so from today, after this till evening, you don't have any commitment, right? So what you can do is you can just revise all the topics, and you all got the material. You all don't need to collect it. I'll give you the materials today. So you all have the study material, right? That is more than sufficient for your boards itself. Okay. So keep preparing that, and by 2nd, imagine that you are going to write a test on 2nd. That is a school exam. Okay. 2nd, write a mock test so that if there is any issue, I can immediately rectify it, and on 3rd, it will help you better. The clear? They're both chapters. Units and measurements and motion in a straight line. For you, it is complete chapter. Those are deleted. So what else is there? Units and measurements. What else is there? Okay, then I'll make it a simple thing. I'll make it a 1 hour test. Okay, because most of the portions are deleted. 1 hour, you keep your mind free that it is. That's what it is important. Because without errors, you cannot step into lab. That's why I don't trust what CBSE has done. Parallax method is fine. Otherwise, you're not going to work on satellites tomorrow itself or stars tomorrow itself. But errors, you definitely need to work on. Sure. So I'll also test because I've taught you and we have done a good number of problems based on it. So it's better you write that also. Okay, these 4 days ensure you're revising and with the mindset that your final exam is on 2nd evening. So prepare in that way so that on the 2nd evening you're going to write a test. So with that, I'll get a clarity on where your mistakes are. Sure. So prepare in that way. Okay. Shall we proceed with problems? there any topic you want me to repeat or anything that is troubling you? Is there any topic that is bothering? Okay, sure. Just show it from there. 3.1. Okay. So. Page number. Hmm. Hmm. 3.1. This one, no? This is what you asked. This is the one. Oh, sorry. Just a minute. Hmm. 3.1 example is your doubt. Okay. There is a car which is moving along a straight line. Okay. Say OP, where you can take O as the origin. OP as shown in figure 3.1. Where is it? This one, no? Okay. So let me clip this diagram. Hmm. So there is a car which is moving along a straight line, say OP, as shown in figure 3.1. So it moves from O to P in 18 seconds. From O to P, it takes 18 seconds. So this is measured in terms of meter. So to travel a distance of 360 meter, it is taking 18 seconds, right? Similarly, and it returns from P to Q in 6 seconds. So O to P, it is 18 seconds, and P to Q, what is the distance? Distance is, yes, it is 120. So to travel that 120 meter, it is taking 6 more seconds. What is the average velocity and average speed of the car in going from O to P? Okay. So what is average velocity? Total? It is total displacement by total time. If you see the object when it travels from O to P, distance is equal to the displacement. Accepted? So when will displacement change? Only when there is a change in direction with respect to the motion of object. So here, when it goes from O to P, distance is equal to displacement. So average velocity is displacement. So how much is the displacement, guys, from O to P? It is 360 with the plus sign because I'm taking the rightward direction to be positive. Right, 360 divided by how much time is it taking to cover that 360 meter? It's taking 18 seconds. So that is going to give you 20 meter per second. So plus 20 meter per second means there is an average velocity of 20 meter per second existing in the rightward direction. Is that point clear? Okay, that is plus 20 meter per second. Now they are asking what is the average speed? Average speed is also the same. The total distance by total time. In this case, it is only 20. Except the fact that you will not put a plus or a minus in front of it. Because speed is a scalar. Remember? Similarly, what is the average velocity when it goes from O to P and back to Q? So when it goes from O to P, the total displacement is plus 360 meter. When it comes from P to Q, it is minus 120 meter. So how much is the displacement? 240 meter. To put it in simple terms, displacement is found by drawing a straight line between the initial and the final point. When you draw it, it is the same 240 meter. So average velocity is total displacement. That is 240 divided by how much time is it taking? 18 plus 6. To cover the displacement, it is taking 24 seconds, right? So 240 divided by 24 is going to give you plus 10 meter per second. Where is x2 minus x1 by t2 minus t? That is when you find the slope. No? That is the slope of a displacement type graph. Average velocity with respect to the graph, that is. If you see the notes that I gave you, did you write down what is average velocity? Check what I have given. You can copy from there. What did I give average velocity as? Huh? Total displacement total by total tendency. So the method of finding the displacement is when you're dealing with displacement, you need to take the direction into consideration because it's a vector quantity. Right? Similarly, if I want to find the average speed, if I go from O to P to Q, what is average speed? It is total distance by total time. Total distance means total path length, irrespective of the direction in which the object has traveled. From O to P, it has covered a distance of 360 meter plus from P to Q, it has covered a distance of 120 meters. So it has covered a total distance of 480 meters when it travels from O to P and back to Q. But all this distance has been covered in how much time? 18 plus 6. So 18 plus 6, right? It is going to be 24 seconds. So 480 divided by 24 is going to give you 20 meters per second. Am I clear with this? Right. Any other doubt? Sure. These graphs? Okay. Write down the heading as graphical representations of, or you can say graphical analysis of motion in a straight line. Those who are online, do you have any problems which you want me to solve?
No, sir.
Okay. So graphical analysis of motion in a straight line. So basically, when you talk about the graph, there are three variables that can come into picture. One is displacement, velocity, or acceleration. Okay. So displacement time graph. If at all I want to draw something like this, when you talk about the motion of an object, what are the three conditions under which the object can move? Or what are the three conditions with respect to motion? If the object does not have a motion associated with it, you call it as rest. So when I talk about rest, okay, then how is the displacement time graph going to be? You yourself think about it. Yes. It can either be a straight line parallel to x-axis or it can be x-axis itself. Why? So if this is time, so when the time is changing along the x direction, is there a change in displacement taking place? Is what the question is. Suppose I take a graph and draw something like this. This also I can say that the displacement of the object is zero, except why? Because as time is progressing, I do not have the object moving. It is at its initial position itself. Or the object could have moved from the initial position to some distance, after which it has stopped. Then what has happened? Then this could have also been a graph. So whenever you see for a displacement time graph, where the displacement is taken on y-axis and time is taken on x-axis, whenever you see a graph which is parallel to x-axis or the x-axis itself, that represents the object is at rest. Does it make sense? Similarly, please make a note. If you have different colored pens on the x-axis, use another color and draw so that you can differentiate. Is this point clear? Right. In a similar way, if I talk about motion, then I can talk about the object under uniform motion or uniformly accelerated motion. See, I can speak about non-uniformly accelerated motion also, but for that, the graph will vary according to the mathematical equation they give you. So clear. So when I say uniform motion, what comes to that? Equal distances are covered in equal intervals of time. When that is a scenario, the speed of the object will be constant. So if I look at speed, speed is the magnitude of velocity. So I will say uniform motion means velocity is a constant, as a result of which acceleration is zero. This we have already discussed. In a similar way, when I say uniformly accelerated motion, velocity is not a constant, but acceleration is constant. Can I take it like this? Right. So for a uniform motion, if I'm trying to plot the graph, which shows the variation between the displacement and time, you tell me how will the graph look like? Suppose the initial position of the object is zero. Suppose the initial position of the object is zero, then where will the graph start from? It will start from this point. And it has a uniform velocity, means the graph will look like a straight line. Is it right? So it will be a straight line like this. Suppose the initial position of the object is not zero. So you can ask me, sir, how can initial position not be zero? Suppose, let's say, there is a scenario where there is a person who started from this line, this point. Okay. You have seen this relay when you run in a track, when you see from the top view, if you draw a straight line, so when you see the track is actually round, you're able to understand a relay. When 4 people are there, generally every school will have 4 houses. So each house, a student is, a runner is there. So if you look at the track, there is one person standing here. if you draw a straight line, will everyone stand on the same straight line? You're able to understand what I'm trying to say. If you draw a straight line, one will be standing here, one will be standing here, and the other will be standing here, depending on the radius of the track in which they are running. Am I clear with what I'm trying to explain? So this is actually a circular track, but with respect to this person, he is here at t is equal to 0. With respect to the second person, they are at different locations at t is equal to 0. So it is always important which point you are taking as origin. See, for example, if you take this point to be origin, it is not necessary that this person is starting from the origin. His starting position is somewhere else. But at the same instant, t is equal to 0. And this guy's position is something else. It is something else. Okay. And let's say they have started and they are running with the same velocity. They are running with uniform velocity. I'm not just saying if the person A has started with the speed of, let's say, 5 meters per second, he's running with the same speed 5 meters per second. Okay. So if that is the case, then for a person who is starting from here, then the graph for him will look something like this. Because his initial position is not 0, it is something else. But if at all they give you two parallel lines in the same graph, what can you talk about the speed of both the people? Two parallel lines in the same graph. Their speed is same. With respect to a displacement time graph, what does velocity represent? Slope. So remember, in your math, you will learn if the slope of two lines is the same, then the lines are parallel to each other. So I'm just doing the reverse analysis. If two lines are parallel to each other, then I can say slope is same. If slope is same, according to physics, velocity is the same. Means both the runners are having the same velocity associated with them. That is what I'm trying to explain. Is that point clear? Right? So the graph can either be a line starting from the origin, or it can be a graph which is starting from a non-zero y coordinate and it keeps extending in the straight line path. Is that clear? Right? So this kind of a graph represents that the object is under uniform motion. Okay, make a note. Okay. So for uniformly accelerated motion, I'll draw it separately, but you can copy under the same heading. You can copy it here itself, but I'll draw it at the bottom. So for uniformly accelerated motion, what is the relation between displacement and time? S is equal to ut plus half at square. In this itself, I can think of two scenarios. If u is 0, S would have been half at square. If u is not equal to 0, it would have been ut plus half at square. Okay. So with respect to this, what I can do is, if I draw a graph, yesterday I saw that sir was teaching you functions, saying that he taught you some graphs, right? So what are all the equations you have learned? What are all the different kinds of functions you have learned? Identity function. You've learned what is an identity function. Y is equal to x. That is the first function that will be there. So y is equal to x will be a straight line passing through origin. Then did you learn about the polynomial function? Not it? Okay. So last year, if you recollect the basics from your 10th standard, you had a chapter called Quadratic Equations and Polynomials. We'll go back to quadratic equation. So for a quadratic equation, what is the general equation of it? Ax square plus bx plus c is equal to 0. If that equal to 0 is not there, it would have been a polynomial. ax square plus bx plus c is a polynomial. What is a polynomial? Polynomial is an expression which contains terms where the terms are the combinations of constants and variables raised to some power. If I make it equal to, it becomes an equation. So a second degree polynomial becomes a quadratic equation when I put an equal to sign and equal to 0. Last year, you would have learned this. If a is greater than 0, you will have something like this, provided it has two real roots, two real and distinct roots. Sometimes a is greater than 0, but if it does not have any real roots, the graph will look something like this. If it has real and equal roots, then the graph will look something like this. Provided what? A is greater than 0. What is A? It is the coefficient of x square. Correct? Similarly, if A is less than 0, what does it represent? So what is the name of this curve, first of all? So it's a downward parabola. Correct? So you know what is a parabola. You learn about a parabola this year. So basically, a second degree equation in one variable. I repeat it. Second degree equation in one variable. What do I mean by that? It is a second degree equation because the highest power of the variable is 2. And if you look at the expression, there is only one variable. What is it? X. Second degree equation in one variable represents a parabola. It represents an upward parabola if the coefficient of x square is positive, and if the coefficient of x square is negative, it represents a downward parabola. There is reason why I spoke about it. Now, if I look at this, s is equal to half at square. S is on which axis? Y axis, and t is on x axis. So can I write this as y is equal to half ax square also for time being for me to understand? Right. So if I observe on the left hand side, y is the variable on the y is the dependent variable, x is the independent variable. So y is equal to half ax square should represent what? X square, and the coefficient of x square is a by 2. And if I say the object is uniformly accelerating, means a is greater than 0. Does it make sense? I'm repeating it again, concentrate. X square is a variable. Okay, what is the coefficient of x square? A by 2. What does a in physics represent? Acceleration. If I say the object is accelerating, acceleration is a positive value or a negative value? Positive. What is the negative of acceleration called as? Deceleration or retardation. In this equation, s is equal to half at square. I'm saying the coefficient is positive. So what is math telling us? If the coefficient of the second degree variable is a positive value, what does it represent? It represents a parabola in upward direction or downward direction? Upward direction. So s is equal to half at square. Now the graph will look something like this. Actually speaking, it should have been a parabola like this. See, I could have directly told you that this is the graph and accept it, but if they ask a different kind of question, you'll not be able to answer it. Is this not looking like a parabola? This is a parabola, please. Correct? But if you see with respect to physics, I'll draw the graph only from origin. Why? But generally, we don't take time to be negative. And acceleration, positive na upward parabola. Left hand side, I don't take the time to be negative. Generally. So you take initial time generally to be 0. So this is the graph for uniformly accelerated motion with u is equal to 0. What is u equal to 0? The initial velocity is 0. Am I clear with this? Right? So this one you can call it as graph A. Very clear? Shall I proceed? Now the question is, what if u was not equal to 0? Can you guess what would have happened? Why do you want to make time? It is something similar to the previous explanation. You drew previous graph of two straight lines. It is something similar to that. Line will start above x-axis. So if I say s is equal to ut plus half at square, again you are able to observe that there is a second degree equation because t is having the highest power as 2 and it is an expression of single variable. So it represents an upward parabola again, but the only difference is the upward parabola starts from where? A non-zero point on the y-axis. So the graph will be something like this. Is it clear? So this will represent ut plus half at square. Mostly in competitive exams, they'll ask graphical based questions. This is all about displacement time. Provided here also the object is accelerate. I hope it is clear. So now we need to look at the velocity time graph. So when I talk about velocity time graph also, again I can speak about two things. One is rest and the second is motion. Again under motion, what can I speak? Uniform motion and uniformly accelerated motion. So uniform motion means v is equal to constant and acceleration is 0. Here v is not constant and acceleration is not equal to 0. So you guys are going to tell me, how am I supposed to draw the graph when the velocity of the object is 0? So I'm interested to draw the VT graph. VT means I need to draw the velocity time graph. So velocity on which axis? Obviously on the y-axis and time on the x-axis. If I say the speed of the object is 0 with respect to time, means time is running, but the speed of the object is not changing, then how does the graph look like? Correct, rest is on. But rest is how will you represent it graphically? So if you draw a parallel line to x-axis, I'll tell you what's the issue. If I draw a parallel line to x-axis, you know what I'm trying to convey? That this will be the initial velocity. If I say this is 0, u, I'm trying to say that the initial velocity is not 0. Some value is existing. That should not be the case. So correct yourself. What is it? Should start from origin and how should it go? It should be along x-axis. The only thing is, it should have been on the x-axis itself. This is the right graph. So when you have a velocity time graph and they have given you a straight line along the x-axis itself, what are they trying to indicate to you? What graphical language are they trying to speak with you? Simple, right? Instead of using the words for a diagrammatic representation, that's it. So it's not so complicated. Don't overthink also. instead of me saying that the object is at rest, I am choosing a velocity time graph. இது வந்து ஒரு dictionary மாதிரின்னு வெச்சுக்கோங்க. You played dictionary, right? ஏதாவது you draw diagrammatically and say that find out the word. அது மாதிரி தான் meaning இது. Okay. So you put the velocity time graph and they give you a graph on the x-axis. They are trying to tell you that the object is at rest. Okay. So velocity of the object is 0. Breathe. So v is equal to 0 in terms of English means rest. Shall I proceed? Okay. So for uniform motion, you guys are going to tell me that is when velocity is constant and acceleration is 0. What does it represent? English. Velocity is constant. If something is not changing, right? Y parameter is not changing. It is a line parallel to x-axis. Simple. So it will be a straight line parallel to origin. And one more point to be noted here is with respect to the velocity time graph, what does the slope represent? So this is velocity is equal to constant. And remember the fact, if the line is parallel to x-axis, its slope is 0. I repeat it, line, or I'll add another point for x-axis and line parallel to x-axis, slope is 0. Yeah. Why? Because what did I tell you is the definition of slope? Slope is tan theta. And the theta is another. Theta is the angle made by the line with the x-axis. If a line is parallel to x-axis or it is x-axis itself, what is the angle it is making with the x-axis? 0. Then what is tan 0? 0. That is why a line parallel to x-axis or the x-axis itself has 0 slope. So using the same logic, I have to ask you a question. If a line is perpendicular to x-axis or if the line is y-axis itself, then what is the slope of it? Using it is not 1 and a 45 degree or not. It's not defined because tan 90 is what you're going to get. It's infinity basically, or not defined as actual term. Purida. So what does this mean? When they give you this kind of a graph with respect to velocity and time, if they ask you about acceleration, what can you say? All these can be 1 mark questions. Okay. What can you say? Obviously, it is going to be a 0. And what would be the reason for it? Slope of velocity time graph represents acceleration. Since the line is parallel to x-axis, acceleration is 0. Purida. Okay. Similarly, if the velocity is not a constant and acceleration is not equal to 0, then what does the equation represent? V is equal to u plus at. This is one of the equations of motion. Correct? So V is equal to u plus at. What does it represent, guys? Hey, those who are online, are you following? Hey, those who are online, are you following?
Yes, sir.
Good. Again, when I say velocity time graph, V is equal to u plus at, there are two scenarios possible. What is it? It's exactly similar to what we did in the previous case. I can say initial velocity is 0. If I say the initial velocity is 0, what would have the graph been? V is equal to 18. Okay, V is equal to 80 represents less simple. Okay, how to recollect the concepts. These are all your 10th standard basics only. I'll just tell you. V into the y-axis is equal to A into where is T? on the x-axis. Y is equal to ax. What does it represent? It's a linear equation in two variables. Yeah. Ax minus y is equal to 0. Makes sense? Right? Linear equation in two variables from your 10th standard basics. What does it represent? It's a straight line. And remember, linear equation, any equation in this world, I repeat, any equation in this world which does not have a constant in it. What do I mean by constant is ax plus by plus c is equal to 0. Linear equation in two variables, sir. Ax plus by is equal to 0. There is also a linear equation in two variables. But even before you draw a graph, what you can first say the function that I wrote will never pass through. And if any line passes, any line or any curve passes through origin, 0, 0 should is equal to 0. If y as 0, then what does it give you? It tells you c is equal to 0, means the constant should not exist. So any equation, I'm not talking about straight line alone, any equation constant and will pass. Have S is half square and y is half into in this equation. Sorry. Sometimes it gets stuck. S is equal to half at square plus, so y is equal to half ax square is there. No? So in that y is equal to half ax square, if you see there is no constant added to it. So since there is no constant added to it, look where the graph started from. So there is a general whichever graph, whichever equation you see. For example, y is equal to ax cube plus bx square will pass through origin. Substitute 0 and 0, 0, 0 and c. Left hand side will be 0, right hand side will be 0. Otherwise, if the equation is y is equal to ax cube plus bx square plus 1, will 0, 0 satisfy? 0, 0 left y. In the place of y, what will you put? 0. In the place of x, you will put 0. And 0 is equal to 1 and 1, which is a mathematical absurd. It doesn't happen. You're able to understand? So this is a very, very, very important point which I want you to make a note of. What did I tell you? Any mathematical expression which does not have a constant added to it, any mathematical expression which does not have a constant added to it will always pass through. I repeat, any mathematical expression which does not have a constant added to it will always pass through what? 0, 0. Will always pass through 0, will always pass through 0, 0. Seriya? If adhe logic you tell me, I'll come back from the beginning. See, I'm eliminating this. I am interested to draw the graph between velocity and time where the acceleration is not equal to 0. When acceleration is not equal to 0 and it is uniform. Here I told uniformly accelerated motion. V is equal to u plus at is the first equation of motion for uniformly accelerated motion. Correct? If u is 0, if the initial velocity is 0, I told final velocity is not 0. It's not a constant. But initial velocity can be a 0. Appa v வந்து என்ன இருக்கும்? It will be at. V is on which axis? Y axis is equal to some constant into x axis. So this does not have a constant added to it. It should be a line. How did I say it is a line in the first place? How it is a linear equation in two variables. So linear equation itself represents straight line. Seriya? So when it is a linear equation in two variables, enna sollana, it is a line passing through the origin. So if they give you a graph like this, what can you say? The initial velocity is 0 and the acceleration of the object is a constant. So how will you say it is constant? For a straight line, slope is always a constant. I repeat, for a straight line, slope is always a constant. Purida. Similarly, this is part A. If I call this as part A, then what about part B? If I say V is equal to U plus AT, guys, where I'm saying U is not equal to 0, then what would have happened? It is exactly the same logic as what happened in 1B. What is it? Exactly the same. The graph will not start from 0, it will be shifted in the upward direction. Can you draw and show it to me? So for S is equal to ut plus half at square, where did the graph start from when u was not equal to 0? It started slightly above, right? In a similar way, this is also a straight line only. V is equal to u plus at. It's a linear equation in two variables, straight line. But it will be slightly shifted in the upward direction. Okay, you're able to understand? Which one? A, did you understand? A brilliant. That you understood? Sure. A little bit you should be confident. What is confusing you? It's like how curved are. Curved are, right? It's a second degree equation. T with the power of. So T then x-axis. So S is equal to ut plus half at square. The highest power of T another. What is the highest power of T in S is equal to ut plus half at square? Highest power of T. It's a second degree equation. So second degree equation in a single variable represents a parabola. Another curve there. Whereas B is equal to u plus AT. Look at the right hand side. T the highest power another. T with the highest power. B is equal to u plus AT there. One then it's a linear equation. Linear equation represents straight line. Another straight line. So depending on what is the highest power of T, you have to draw the graph. So basically, what are the three equations of motion space? B is equal to u plus AT. S is equal to ut plus half AT square. B square minus u square is 2as. V square minus u square is equal to 2as. We don't draw the graph at all. Okay. B is equal to u plus AT and S is equal to ut plus half AT square. B is equal to u plus AT. What is the highest power of T? Highest power of variable is 1 linear equation by default straight graph. Only thing you need to be careful about is where the graph is starting from. So that is decided by whom? That is decided by the initial velocity. So adhe mari. So what I'm trying to say is in the first one, V is equal to u plus AT. Since u is 0, it started from origin. If a V is equal to u plus AT, if u is not equal to 0, it will not start from origin. But it's still a straight line. So it will still be a straight line. Means the first graph is there, right? This graph. It is like this graph has got shifted here. Okay. Am I clear? So what does the slope of a velocity time graph represent? Slope represents acceleration. What does the area represent? Very good. Area represents displacement. So slope conducting, what is the mathematical operation I'm supposed to do? Slope conducting. Difference or delta y by delta x. So wherever you see the word slope, you need to differentiate. Differentiate with respect to whom? With respect to x-axis. Differentiate with respect to x-axis. If I want to find the area, I have to integrate with the, or WRT na theriyada, it is with respect to x-axis. So in physics, x-axis is always time. Most of the scenarios, x-axis is always a time. Am I clear? So what is the next graph that we are supposed to do? Displacement, velocity, acceleration. So we saw displacement time graph. We saw what is velocity time graph. Up next another. I need to see what is acceleration time graph, where acceleration is again taken on y-axis and time is taken on x-axis. Is this clear? So again, I'll describe two things. One is rest, then motion. Under motion, V is constant, V is not constant. So when the object is at rest, then how will the graph, acceleration time graph represent? When the object is at rest, velocity is 0. When velocity is 0, what about acceleration? 0. Acceleration 0. Velocity, how will object accelerate? Correct? So acceleration is 0. So what should it represent? It should represent the x-axis again. Is the point clear, guys? One minute. Not sure if you have to see that line. The red color line at the bottom. So that represents that the object is at rest. So the conclusion is, for a velocity time graph and acceleration time graph, when the object is at rest, the graph is always x-axis. Now you know the reason why it is. Correct? You know, anything is 0. Y-axis is 0 means x-axis is simple. Correct? So motion, if I say velocity is constant, I'm repeating, if I say velocity is constant, okay, then what will happen to the acceleration? If the velocity is constant, can I say acceleration is 0? So again, if acceleration is 0, what should it represent? Same thing. So this graph itself represents rest as well as acceleration of the object is equal to 0 or uniform motion. So for rest and the uniform motion, what can I conclude? The acceleration time graph is x-axis itself. Then, when velocity is not a constant, but acceleration is a constant, then how will the graph look like? Velocity is not constant, but acceleration is constant. Acceleration and the y-axis. If y-axis is a constant, then what does it represent? It represents a line. It is a line which is parallel to x-axis. So this graph represents a uniformly accelerated motion. So for the same terms, rest, uniform motion and uniformly accelerated motion, the displacement time graph is different. It has something different to tell us. Velocity time graph is slightly different and acceleration time graph is different. The shapes are different, but they convey the same meaning. Right? Velocity is constant, acceleration is by default 0. If acceleration is 0, it will start from origin. Means from the beginning you are saying that the object is not accelerating. That is what I'm trying to say. Let's say you're riding a bike. Okay, when you turn the accelerator, let's say the bike has started with 20 kilometers per hour. If you take that to be t is equal to 0, and let's say for 10 minutes you're driving only with 20 kilometers per hour. So from that 0 seconds to that 10 minutes or 0 minute to 10th minute, you're still driving with 20 kilometers per hour. Have you accelerated? That is the meaning. Did you accelerate? What is the meaning of acceleration? Forget the technical term. Acceleration, imagine with respect to a bike, means you need to go from the 20 to some other value higher or some other value less. But what did you do for the next 10 minutes? You kept your hand like this and you're going with the same speed. Means you have not accelerated. Is this point clear? Right. So this is also an important problem. So this is all about graphs that I've explained already. Okay. This 3.2 is also an important problem. Let's try to solve it. So if you see, the position of an object moving along the x-axis is given by x is equal to a plus bt square. So what is the expression they have given? X is equal to a plus bt square. Suppose I'm asking you to draw a graph between x-axis and time. What shape will it take? How did you say that? Highest power of time is 2. Wait, where will the parabola start from? Will it start from origin or will it be shifted upwards? It will be shifted upwards because there is a constant added. But that's not our headache. I just wanted to test you whether you have understood or not. So x is equal to a plus bt square, where a is 8.5 meter and b is 2.5 meter per second square. And t is measured obviously in seconds. What is the velocity at t is equal to 0? So what is the velocity at t is equal to 0 and t is equal to 2 seconds? And what is the average velocity between t is equal to 2 seconds to t is equal to 4 seconds? So try to understand this. So based on the preposition that is used, you need to find out whether it is an instantaneous value or average value. So when they use the word at, it is instantaneous value. When they use the word between, velocity between, it is an average value. Okay. So to calculate instantaneous value, the procedure is differentiate and substitute time. Okay. Whereas to find average value, substitute time and find the slope. Slope means what? Change in y-axis divided by the change in x-axis. Change in y-axis divided by the change in x-axis. Okay. So x is equal to a plus bt square. So for me to find the velocity at t is equal to 0 and the velocity at t is equal to 2 seconds, what do I need to do? Differentiate on both sides. Dx by dt is how much? Derivative of a constant is 0 plus b into derivative of time square is 2t. So dx by dt represents velocity. So differentiate and substitute time. So dx by dt, you put a line like this. Line like this in math represents at. At the bottom, put a subscript of whatever time you want. At t is equal to 0. How much is that? It is going to be 0. Did you understand what I did? So what is the meaning of this? This is the velocity of the object at t is equal to 0. Dx by dt varaikkum puriyada. This is clear. Dx by dt is equal to 2b into t. So how do you read it? Is read as dx by dt at t is equal to 0. So write down the variable, put a line, and t is equal to 0 represents. You need to take this value 0 and substitute it in the right side expression. So when you substitute it, 2b into 0 is obviously going to be a 0. From this, we can conclude that the velocity of the object at t is equal to 0 is a 0. This is the instantaneous velocity. With a similar logic, find out what is the instantaneous velocity at t is equal to 2 seconds. 2 minutes time, do it fast. Sorry? D is how much? 8.5. 2.5. Okay. 5 into 2. Then what is the unit? Sorry, ma? Correct. So how many of you could do it? You got the answer. You didn't get it. Huh? Simple. X is equal to a plus bt square. Question, you know when to find instantaneous value. At the instantaneous value. Then what will you do? Dx by dt is equal to 2bt. No doubt in that. Correct? Huh? So what are they asking? Dx by dt is velocity. At what time? T is equal to 2 seconds. So wherever you have t on the right hand side, substitute 2 there. So 2 into b is how much? 2.5 into time is 2 seconds. So 4 into 2.5 will give you 10 meters per second. They've given, no? So it is 10 meters per second. Am I clear? Right? Similarly, they want us to find the average value. So average can first substitute the time and then find the slope. So for average value, substitute the time. X is equal to a plus bt square x. Okay, I'll do it separately. See. Let me copy this question again. So see, x is equal to a plus bt square. X of, they're asking between 2 seconds and 4 seconds. So what is the value of x at 2 seconds? A plus the functions y is equal to f of x. So if I give you y is equal to 2x square plus 1, If I ask you what is y of 1, what will you say? 2 into, in the place of x, you will substitute 1 square plus 1. Wondering, it's the same logic here. Did you learn or not? F of 1 or we can say y of 1 also. There is none. So variable bracket, if you put something, you're saying at that instant you're trying to find an answer. So x of 2, what is it? A plus 4b. That's it. Okay. X of 4 another. A plus 16b. Okay. So they're asking the average value. For average value, find the slope. So x of 4 minus x of 2, final minus initial, divided by t, or else say, what is the final time? 4 seconds minus initial time is 2 seconds. So what will you get? X of 4 is a plus 16b minus a plus 4b divided by 2. So a and a will get cancelled. 16 minus 4 is 12b divided by 2, which will give you 6b. That is going to be 6 into, what is the value of b? Again, it is 2.5, which will give you 15 meter per second. Means the average velocity between 2 to 4 seconds is 15 meter per second. But the instantaneous velocity at t is equal to 0 is 0, and at t is equal to 2 is 10. I didn't get you. You can use it, but you don't know what is the total displacement. That is, you ask me, what is that x2 minus x1 by t2? This is what is x2, this is x1 by t2 minus t1. So you have final minus initial divided by final minus initial. Clear? Now we'll just try to analyze these graphs that are given. You can do it fast. So figure 3.9 shows the position time graph for motion with. So if you observe, the first graph is what? It's an upward parabola. So it's an upward parabola means acceleration is positive. If it is a downward parabola, acceleration is negative. If it is a straight line like this, then acceleration is 0 because it is moving with uniform velocity. Similarly, when I have the velocity time graph, if the graph is a straight line like this, what can you say? Acceleration is greater than 0. If it is a straight line in this manner, means if you see as the time is progressing, velocity is decreasing, then you can say acceleration is less than 0. Okay. So if you observe this kind of a graph, so what can you say about this? Point C is given C. Motion in the negative direction with negative acceleration. So what you can conclude about this is motion in the positive direction with positive acceleration. This is motion in the positive direction with negative acceleration. This one represents motion in the negative direction with negative acceleration. And what about this graph? Motion in the positive direction with negative acceleration till t1. After t1, motion in negative direction with negative acceleration. So what you can say is, this is a classic example of where an object is thrown in the upward direction. So when you throw an object in the upward direction, first what happens? If you throw it from here, it goes to a highest point. So velocity is decreasing. How did I say velocity is decreasing? Because initially you are giving some velocity. When will the object be able to change its direction? Suppose you are running here. Okay. You're running in this direction. If you want to change your direction, how can you do it? Because you need to come to halt and then take a turn and then come, or you have to at least get slowed down. Right? In a similar way, when you throw the object upwards, you give some velocity here. At the highest point, it becomes 0. So the object from a maximum velocity has got decreased to 0 at the highest point. So it is decelerating. Correct? Is it decelerating or accelerating? Decelerating another. Velocity is decreasing with respect to time. That is the meaning of negative acceleration. So when you go from 0 to highest point, it is decelerating. After that, what is happening? The direction of the object is reversed. So direction of object is reversed and it starts accelerating. That's meaning. Okay. So area under the velocity time graph gives you the displacement. You know this fact. Right. What does the area under the acceleration time graph give you? What does area under acceleration time graph give you? It gives you velocity. So area under acceleration time graph gives you velocity. Okay. So the possible questions that you can get is, they'll ask you, I don't think you have equations of motion also, right? Derivation, they should ask you only problems based on average velocity, average speed. All graphs are there, they'll ask you from the graphs and all those things. Okay, that's it with all the graphs also. Maybe I need to do few more problems. I'll prepare some questions by the next class. I'll do some problems based on graph. Apart from that, is there any other point you want me to explain? So I'm not going to relative velocity today because too much information will confuse you. Again, I have to explain graphs. I'm not going into that. Apart from that, anything, any other point which you want me to explain which is not clear? Between. What is it? It's just a basic graph that tells you that the acceleration of the object is positive. So it doesn't convey anything about what is the initial position or anything of that sort. It doesn't convey anything. Whereas the graph that I gave you tells you that the initial position is not 0. Okay. So what they try to convey is, they are saying if you have an upward parabola for a displacement time graph, then you can say that the object is uniformly accelerating. If you have a downward parabola, you can say that the object is uniformly retarding. If you have a straight line, you can say that the acceleration is 0. That is what they wanted to convey. Okay. So that's why I told you there are the problems, right? It is slightly different because the problem they'll tell you the exact configuration with respect to the graph. They'll say where it started, why it is starting from this point. If this is the case, how will you find the velocity? How will you find the acceleration? There are some interesting problems that are present that I'll explain it tomorrow. Okay. Apart from that, any other topic that you want me to explain? Limit delta t tends to 0 means delta t is a very small value. in calculus we use this word called as infinitesimally small. So calculus is all about approximation. I so it will be too much for you. So in calculus we use something called as whatever value you're trying to find is an approximate value. For example, instantaneous velocity of finding, it is an approximate value. Means the value will not exactly be 10 meters per second. And the problem that we didn't know, we got the 10 meters per second. It will not be 10. It will be 9.999999998. Small value. So that value is actually approximated to 10. Okay. I'll tell you why calculus was found is only to solve problems based on instantaneous values. And calculus is all about approximations. So delta t, as of now, you don't worry about it. As of now, accept it. There is a chapter called limits and derivatives in your math. At that point, you will understand. But you need to have patience to it. Anything else? Is everything clear? So I think you have simple questions only for your exam also. So work on that. If you have any doubt, make sure that you are working today and come up with doubts tomorrow. We'll have a lot of doubts, clearance, and 45 minutes I'll do problems. 45 to 50 minutes I'll do problems. Next 45 minutes I'll allot for doubt sessions. I'll not teach anything extra tomorrow. Sorry, so prepare sincerely today so that you complete physics, and on 2nd of August you are writing a test. Don't say on that day again I need to sit and prepare. Just be ready for this. Sorry, complete it. If you have any other doubt, if at all you say you can't wait till tomorrow, you have the student support number, right? So there is a number. I hope everybody has made a note of it. I repeat it again: 6369210899. I'll be available on that number. You can just message. So you can take a screenshot and send it. If you want to send a voice note, do send it. Only thing is, don't call me because I may not be able to attend the call. You can drop a WhatsApp message. If anything is not clear, and I want the voice note. That's it. That itself should be. So those who are online, are you clear, guys?
Yes, sir. Clear, sir.
Very good. Okay. So I'm also expecting a few more questions from you tomorrow. So prepare sincerely and make sure your doubts are consolidated and brought to me. Okay. That's it. We'll wind up then. Yeah.
Thank you, sir.